So we're talking about jigs and fixtures and solutions, and that's really the term I prefer, is solutions. These are all shop solutions. There's all kinds of information on what's the difference between a jig and a fixture. For me, it doesn't matter. I don't care. It's just I need something, and so I'm going to get it or make it. So when we're doing the work that we do, we always need something in the way of tools or something that we got to go out and get in order to make something more efficient, more accurate, faster, or even to do an operation at all. So we acquire all these things that we have. Now, as we're doing this, for me, and I think many others, we like to make some of our own stuff. So there's a make versus buy decision. And almost everything that I've got here, there's commercial versions available that you can buy, and they're just fine. I very often go out and buy something, but I like to make things. It's fun, it's interesting, it's exciting. I get to tailor them to my own needs and wants. So I do make a lot of my own stuff. So that make versus buy decision comes down to a few things to consider. One is money. The stuff that's available to buy sometimes is just, in my opinion, way overpriced for what it is. I can make it a lot cheaper. Sometimes I need something that just isn't available at all, so I'm going to have to make it myself. Sometimes I want something that is available, but I just don't like all the features, so maybe I can customize it a little bit. So we just go through this thought process, and then we end up accumulating stuff. So what I want to do mostly today is I'm going to show you some of my work and then tie that into some of the things that I have developed to help me do that work more accurately, more efficiently, faster, with some repeatability, etc. And then the process of how I go about making these things. There's always a process to consider. I use commonly available materials. Everything here, you can buy the stuff like at the Home Depot or a local hardware store that you need. So readily available things. And then exploiting the characteristics of those materials. Plumbing supplies, metal supplies, screws, all this stuff is made to standards, engineering standards. And then trying to figure out how they relate to each other. So again, you can exploit some of these characteristics is one of the things that's key to doing the things the way that I do them. So hopefully we can get a little bit of that information out. And then some of the tools that you need. For example, drills and taps. A lot of the stuff I work with is metal. Having drills and taps is really essential. You don't need to go out and buy a whole big box or a whole full set because you wouldn't use most of them anyway. So I buy them as I need them. I've got like 5 different sizes of taps. I said drills and taps. I meant taps and dies. I've got like 5 different sizes that I use of taps and dies, and they come in really handy. So let's get started. And I'm going to be jumping around a little bit, and we're going to be looking at a little bit of finishing, all kinds of things that I've developed. And I got some really unusual things that I've done that just seem to work. So we're going to share a lot of these things with you. If I'm jumping over something, if you have a question, just jump right out there and we'll do our best. Okay, grandfather clocks, wooden grandfather clocks is something I've had a lot of fun with. I've built 10 of them over the years. And a lot of you have probably seen these at the woodworking shows. This is a couple of them, number 8 on the left, number 7 on the right. Looking at the ring that clock face is made of, this is a 12-piece segmented circle. There's actually 2 rings on each of these round clocks, and each ring is made out of 2 separate rings that are sandwiched together because they have to capture the plate that you see in the middle. And we're going to be revisiting that 12-segment ring a bit today, so we'll get this one out of the way. There's a really good website out there for who turns here. A lot of turners. If you go to a website called turnedwood.com, and if you don't remember that, just type in your search term Kevin's Woodworking, And I discovered this site maybe 12 years ago when I was ouch.
We're waiting.
What did I have for supper last night? Anyway, he's still there. This guy does some amazing segmented work. So when I started exploring segmented turning, I found this site. And what Kevin talks about is the use of sleds. And he sells a software program. When I bought it, it was on a 3.5-inch floppy. It was $14.95. I just checked the website last night. It's $19.95 now. Really simple little program. And when you're wanting to make a ring or whatever, and I'll pass these around, you just type in the elements that you want. What's the outer diameter going to be? What's the inner diameter going to be? How many pieces do I want? And then this thing spits out what you need to do that, what the angles are. Yes?
Is that the one that's in Kansas City?
You know, I don't know the answer to that.
Yes. That's where I got mine from.
All right, so this is just a sled. I make most of my sleds, if I can, to ride in both runners, the table saw. And all it is a piece of particle board with another piece of wood that's going to cut a 15-degree miter. I made this, the hole underneath here is about a 1/2-inch diameter, so I can loosen this up and tweak it just a little bit. So when I was setting this up, I wanted to make sure I got this thing dead nuts. I've made 4 of these. The other ones are for compound miters. So if you're turning a bowl where the bottom or the top is going to be segmented, obviously you need that to be a compound miter. And with that program, you can enter as many pieces if you want. If you've seen some of Don Russell's work, you know, he's got like these 64 segments. You can do all that with this program. I'm not making segmented bowls these days, but I really use the heck out of this 12-piece flat ring, as you'll see.
So do you make a dedicated sled for each angle?
Yes. Oh, thanks. And Kevin's woodworking site shows you how to make these sleds. Now for his compound miters, the approach that he takes is he's actually got the fence on the angle, so he always leaves his blade at 90 degrees. I found that to be a little dangerous. I wasn't comfortable cutting that way. So I've made mine so everything is flat and I tilt the blade to the angle that I need. So to make a compound miter, you might have a 15.375 degree miter and have the blade to some fraction of an angle somewhere. And you can get as close as you can with a protractor, for example, but then you tweak them, and then you just have to make your segments and try it out and see what needs to be adjusted. But once you get that there, you make a sled, and then you've got that, and it's repeatable every time you want to make one of those. All right, this is my number 10 clock. This is all veneer work. In this case, the rings are made of Baltic birch plywood, and it's all veneered. But the veneer around here is a figured mahogany. Let's go back to this one in a second. You can't hardly see it on that picture, but the way I cut these solid wood rings is I'll start with a fairly wide board, in this case red oak, and then cut strips of it off cross grain. So then when I cut my segments, I'll have the grain radially arranged all the way around the ring. It just looks better that way. Then the veneer that I used on this one, I arranged it, actually went to my sled and just cut a segment and used it as a pattern, and then used that to cut my veneers with. And that's arranged so the figure in the maple is radially arranged around the face of the clock. All this veneer work is done with tape and clamped up boards. I didn't use my vacuum press on any of this. Those upright 4 legs on the clock. This clock is about 6.5 feet high. Those legs are rounded, and that's just done with glue tape, cutting veneers and just taping them down real good. And looking at a close-up of the pendulum and the weight. Pendulum, again, 12-segment ring, just another application for that. The weights are made of 2-inch PVC plumbing tubing. They're filled with lead shot. The veneer on that, this is a really nice piece of figured anagray that I use on this clock. My favorite clamp for this kind of work is a bicycle inner tube. So just get a bike inner tube, cut the nozzle piece off it. I slice them into strips just depending on how wide I want them to be. You have to cut that veneer precisely so it's going to fit and joint at the seam. I just put a little bit of slow set. I use a 12-hour epoxy, a real thin coat of epoxy on the veneer, wrap it around the PVC, temporarily tape it, and then take that inner tube and just go all the way around there, just pulling that as tight as you can. And when you get to the end, before the ends are glued in, you've got open tube, you can just take a spring clamp and hold the end of the inner tube in place. Let it sit overnight. It does an amazing job. You can use those inner tubes for all kinds of stuff. It's basically a great big rubber band. But instead of going out and trying to find a great big rubber band. All right, most of my work has been furniture. This is a media cabinet. It's mahogany with bird's eye maple doors, veneered doors. There's a 50-inch plasma TV behind those top doors. This is a little console table. The reason I brought this one is I wanted to show you one of my oddball finishing techniques. Start passing this around. This is just red oak. When you put a finish on oak, as you'll see when that first piece goes around, you're not going to get a nice glassy finish. Oak has to be filled. And oak is really grainy. So that piece, you can feel it, you can see it, you can hold it up to the light, and it looks like you're looking at a mountainous scene. There's all kinds of fillers on the market. And to tell you the truth, I've never tried a commercial filler. Every time I look at a quart of it for 25 or 30 bucks, I say, nah. So this thing I developed years ago. This was my prototype sample that I used for that table to make sure this would work. And I bought, and I still use this today. It comes in a cardboard canister. You can get it at the home center. It's called Durham's Rock Hard Water Putty. And I just take a bowl and I mix a little bit of that with some pre-mixed bullseye shellac. I get a kind of a slurry, and then just take a trowel, one of those little plastic trowel things, and trowel it into the wood. And this piece has that in it, and it's already been sanded, and it's yellow because that's the color of the water putty. But when I mix that up, if I put just a couple drops of pigment in there, you can use a walnut stain or anything that's going to turn it brown, and then put it in there, and it will match the oak. And then finish it. In this case, this is just Minwax polyurethane, 3 or 4 coats. My last coat, I always wet sand. I wet sand this down to 600 grit. I've got an old orbital sander that I use that I don't mind getting junk all over. Just wet sand it with water. If you compare this to that first piece that's going around, you can see quite a remarkable difference. And that's how I get a nice glassy finish on a wood like oak.
That's called rock hard.
It's called Durham's is the name of the company. Durham's Rock Hard Water Putty. It's got like a picture of a muscle man on the label. And again, you can buy that for just a couple of bucks for like a big old canister. It'll last you forever.
And mix it with.
I mix it with shellac. It's designed to be mixed with water. That's why it's called water putty. And it does dry hard as a rock. I was a little leery about using water because I was thinking maybe shrinkage. So I actually mixed it with shellac. And of course it's going to harden up real quickly. So you have to mix up enough so you can do little areas at a time. But it works remarkably well.
The shellac does activate it like water? So
Yeah, it does.
Okay.
Yeah, it's just, again, this is one of these out-of-the-box kind of things where you just come up with these ideas. What if I tried this? And half the time you end up with a mess and you say, okay. It's like when Thomas Edison was looking for a filament for his light bulb, and he tried thousands of things. And he always had a positive spin on things. And they said, didn't you waste a whole bunch of time going through all this? And he said, hey, I know 1,000 things that don't work now. And that's part of the process. This is a dining set, table, 6 chairs, and a hutch. We're going to, not showing up real well on the screen, we're going to revisit that. This is a segmented bowl that I did. In the middle we have, everybody, a 12 segmented flat ring. That's a piece of zebra wood. Again, I had about an 8-inch wide board and I cut strips cross grain. Each strip got layered on each side with an 1/8 inch thick piece of hatoba. And this is how you glue those up. That's the 12 segments glued up, ready to dry, and that got stuck to one of the halves and stuck on the lathe. And these halves are made of big leaf maple burl. There was a time this stuff was all over the place. I remember I used to go to Hardwoods Inc., used to be Atlanta Wood Products, and they'd have pallet loads of this stuff. And they were fairly cheap. And they're burl caps. Everybody knows what I'm talking about, right? And just I used to buy those and turn bowls out of them, but they're really scarce these days. I guess the source, the people that were sawing these aren't doing it anymore. Heard some stories about that, but when you do find them, and you can find them, they're expensive. It's probably 150 bucks worth of burl caps. And this is like a 14-inch diameter bowl. So it's disappointing you can't get those anymore. And then I make decorative objects. This is a music stand and a plant stand. I've made a lot of these over the years. That ring in the middle of the plant stand, guess what that is?
12-segment ring.
Yeah. In that case, it's about a 6-inch diameter ring. Started out with 3/4 inch stock, and I just took that to a router table with a 3/8 roundover bit. Just free-handed the inside and then the outside to make that whole thing round. Alright, my latest thing, I'm doing acoustic guitars now. These are really jig and fixture intensive. This is a big leaf curly maple guitar. I found a really nice board at Hardwoods Inc. that just happened to be there. It was like 13 inches wide by almost 10 feet long, and just, yeah, snatched that bad boy right up. And then milled it up and got enough wood to make 3 guitars out of it. That's the top of that guitar. So that's going to bring me to this. This is, I've only made one of the maple guitars, but I milled all the wood up at once. This is one of the sides, or it's going to become one of the sides for the guitar. This is 80 thousandths thick, so less than 1/10 of an inch thick. And the tool of choice for doing this, once you resaw it, is a wide belt sander. The 2 halves on the back of that guitar, they're 8 inches wide. So usually you glue those up and then put them through a wide belt sander. But I don't have a wide belt sander. And you can rent time on those things. Woodcraft will charge you like 65 bucks an hour. And yeah, okay, well, maybe. But I don't have a sander, and I don't have a place to put it. I'm going to show you some pictures of my shop, and you'll see I'm working out of 300 square feet in my basement. So, can you do this on a thickness planer? Generally, it's thought no. I have an older model, 12.5 inch wide Delta portable planer. I don't think you could do this on a bigger planer, but that one won't even lower far enough to do this. But what I have is a 3/4 inch thick piece of MDF that I just lay on the planer. It covers, you open up the wings of that thing, and it covers the whole bed. It gives you a nice flat reference surface, way better than what's available on the stock model. And it also raises the table up so you can bring the blades all the way down. And it's got a little lip, just a little overhang glued to the end of it that overhangs the infeed table so it doesn't get pulled through the table. Okay? So for this, I'm going to pass this around. You'll see there's a little bevel cut on the edge of each side. And I can feed this through, and you know when you're using a hand plane, you go on an angle to get that shear cut. So I'll feed this through the planer on an angle. And you got to have really sharp blades. The blades on those old Deltas are reversible. Wear one side out, use the other. And the first time I replaced those blades, I paid 13 bucks for them. Today they're like 50 bucks. But anyway, you got to have good sharp blades. And you just take it down, and you got to be patient. And it's almost what would be called air planing. Your first pass, you're just taking air. And if you're real careful, and what this bevel does, instead of having a blunt edge for those blades to hit, it'll catch them and break the wood. It just lets the blades introduce, and it works really well. And again, I can get, this is as thin as it needs. I'm sure I could have gone thinner, but this is 80 thousandths thick, done on a thickness planer.
You do those in a, like say, do 10 or 12 of them at a time at the same?
Oh yeah, yeah. When I'm doing sides, I'll just do all my sides. The backs are 100 thousandths thick, and the tops, which in this case Sitka spruce, which you can't buy good Sitka spruce locally. I haven't found it, so I have to order this stuff. And it comes about 1/4 inch thick, and it's very pricey. So, but those go through the planer too. And again, just really careful, being real patient with it. The tops is about 120 thousandths thick. Yes?
You pass these through on your MDF table, and you did these at a slight angle pass through?
Yeah, as much angle as I can get, as a matter of fact. And that way I'm getting that good shear cut.
Did you wax that MDF tabletop with
Nope,
it?
nope, didn't do that. And when I first tried this, just to be safe, I actually double stuck taped this to a piece of MDF, and particularly taped those ends down so they weren't flopping around. And if I'm doing a bunch of them, I gotta keep doing that to every piece, and it was taking too much time, so I tried it without that, and I decided I don't even need to do that. I just can feed them right through.
How do you hold it? How's it being held to that MDF?
Just the pressure of the infeed rollers, or the feed rollers.
MDF is just raising the table is all this.
Yeah, all the MDF is, that's my reference table. The planer comes with these little wing things that you open up. So it's got that one, and it's got the stationary table, and then another one, and there's a gap in between them. So the MDF just gives me a good, flat, consistent table. And whatever I'm planing, if I'm planing something that's gonna be 3 inches thick, I always use that MDF. It's just
So it goes all the way through the planer?
Yeah, it sits on, it just sits on the planer stationary. And again, I'll show you a picture of it later. It's got a MDF board with a little lip screwed to the end of
Okay,
it.
I understand now.
Yeah, and that lip just rests against one of the infeed tables so that doesn't get pulled through.
So the MDF remains stationary and the
Yep,
piece that you're working on slides across the top of the MDF?
exactly. The MDF just becomes the planer table.
Then you made a nice output, then you just made it longer, so it has a nice output table on it too, probably.
Not much longer.
Okay.
But no, just basically the length of the table. Could make them longer and then support it. There's nothing wrong with that.
Look, one other question, do you run the MDF through the planer before you use it to make sure that the top of the MDF is parallel to the blades?
Good question, but no, I didn't.
Tough ones to lift.
Yeah, and it's tough on the dust collector too, MDF. But MDF is really flat, and that's as flat as we're going to need for anything that we do in woodworking. Where I used to work, we needed a flat reference table for aluminum doors, and we were looking at granite for tens of thousands of dollars. We just built a nice big frame with and put a piece of MDF in there, and then put a piece of 1/2 inch thick glass, tempered glass on that, and it was just as flat as we needed. But you know, MDF is flat, so I haven't done that. It probably wouldn't hurt, but MDF also has, when you cut into MDF, inside isn't the same as the commercial surface, so that slick, nice, smooth, prepared surface is probably best to leave it that way.
How about melamine for that?
It would work. I haven't tried it, but it would work just fine. All right, this is, by the way, that's my number 3 guitar. I just sold that one.
What's the name on the top of that?
That's my logo I came up with. That says Janton. It's J''Anton. And since you asked, my grandfather's name was Anton, my maternal grandfather. He was a woodworker, a very creative guy. I've got some of his old tools. I like to think I got my proclivity from him. So Anton, that's part of that name. The J is for me, James, and then my father's side of the family is French, and they're full of musicians and artists. My dad was a drummer, so by putting that apostrophe in there, I give it a French kind of a sound. So I got my whole family influence rolled into that name. And I came up with that name years and years ago. I wanted to use it as a logo on woodworking, but it just didn't feel right. But when I started making guitars, it just seemed, yeah, that's where that name belongs. But thanks for asking. Appreciate
So
that.
have you got a stockpile, you've got an inventory, orders in the rears to make them?
I got one order in arrears, and you know, it's just kind of word of mouth thing. I've only made 4 of them, and the way I look at it, if you're a musician and you were looking for a custom guitar, custom-made, handmade guitar, would you seek out the guy that's made 4? So yeah, I'm selling them to friends right now, and just I'm learning this process. And I'll tell you what, woodworking, I've been doing that for over 30 years. Really shallowed or flattened the learning curve for this. This is all about woodworking. But in order to make a musical instrument, that's a whole different animal, and that's what I'm learning right now, is how to make this into a decent instrument.
Now, is that a 12-segment ring in there?
That right there, and that one, you can't see it, that's actually an abalone shell ring, and it's made of many, many segments, and I did that by hand, and I came up with a process that's really complex for how I'm going to glue that and hold it and shave it and all that. But anyway, you can buy abalone, and buying enough of it that's pre-cut into the radius to make that rosette, it's called, costs about $30. I went out to Tacoma to the Guild of American Luthiers Conference during the summer, and I bought a bag of scrap abalone from a vendor for $10. And there's enough in there to make 30 or 40 of these rings. But I just had to figure out how to do it, so I wasted enough to make about 3 of them, just figuring out how I wanted to go about doing that. That's just me, I'm nuts. I just refuse to spend money if I can make it. Obviously I have more time than I have money. This is my number 2 guitar, that's a rosewood back and sides. And on this one, the rosette is a 12-segment ring. So for this one I was looking for something unique for the rosette, and I ended up buying a piece 1 inch by 1 inch by 12 inches long piece of what was called black palm. I bought it at Rockler, and it was in the pen making supplies bin, so it's a piece of pen stock. But I really liked the look of it. It's got a very interesting grain. I cut that into 1/8 inch thick strips, and then went to my board, went to my software, what's my diameter, and I figured out the segments, and then I cut these segments. So this brings me to this. First picture on the top left is just the picture of the sled cutting the segments. One on the right is the segments glued together. I've got a little strip of white plastic in between each one for contrast. So it looks like that. I buy that white plastic, I got that at Hobbytown, USA, but any place that they sell stuff for model railroaders, you'll find a display with plastic in it. Tubes, strips, squares, extrusions, all kinds of stuff. And this is just like a little 20 thousandths thick little piece of white plastic. Now, once I get that segment done, I need to cut it into a circle, and that requires a precision router. So that brings me to this thing here. I'm going to pass these around when I get done explaining them, but this is a router base that converts a Dremel tool into a little router. Vanessa, this might come in handy for what you're doing. It's an adjustable plunge router. There's a commercially version of this available. It's, by the way, a really cool website that sells luthier supplies, guitar stuff, is Stuart McDonald. And if you just type in StewMac, S-T-E-W-M-A-C is your search term, it's the first thing that comes up. Commercially, I copied theirs for this. And this one, the circle attachment and the bearing guide, I could have bought all this stuff for about $150, and I almost did. But I can buy a couple of really nice pieces of spruce for $150. I'd rather spend my money there. And I had literally everything that I needed to make this stuff in my shop. I just had to spend a couple evenings putting it together. So again, like I said, there's nothing unobtainable on this. And I was talking about exploiting some of the characteristics of commonly used materials. These are just 3/8 inch bolts, machine bolts, and then you buy the longer ones that have a little bit of thread and a long shoulder. The shoulder is a perfect 3/8 inch. These are just, you open up the drawers for all that hardware in your home center aisle, and you buy these little spacers. They're steel or bronze spacers. Buy a 3/8 one, it's a very precise sliding fit. And of course I made this out of wood. The commercially available one adjust on the post, that was a little too complicated. So this is just a 3/8 piece of threaded rod with a wooden ring on it. And what I did here, it's got to turn freely but still be captured. So I will chuck this up in my lathe, and I do this for a lot of different things I make. And I'll drill a small hole right in the middle of the end of that rod, and then tap the thread. In this case, it's a 10/24 flathead screw. And then you got to shave the screw or cut the screw so when you put it in there it's tight, but it's still loose enough so it'll turn. And you just have to figure out where that is. And then just put a little drop of CA glue in the hole and screw it together. And you end up with this. So the only thing that I couldn't find for this is the threaded part of these Dremel tools. I don't know what it is. It might be a metric thread, it might be a custom thread, but for all the plumbing supplies and nuts and bolts and stuff that I look at, I could not find female to match that thread. So all these Dremel tools have a little cap on it that comes off. So you can put other attachments on it, right? Some of the attachments you buy for Dremel tools thread onto that. So I just decided I don't really need that cap on there, so I'll just take that off and I'll use that for that. So that's embedded in between. There's a sandwich of wood here. You just had to drill a little hole and a big hole. And it's a kind of an oddball shape, so it's all filled with epoxy around it. So that ended up working quite well. The circle attachment just screws on to the machine, and then I can attach that or adjust that for the diameters that I need. This is one of those bronze spacers out of the hardware drawers. Just a piece of 1/4 inch steel rod and a brass washer, and you just put those together and put a couple drops of super glue, thin super glue in there, and that's never going anywhere. So let's take a look at those things. And then this also screws onto the bottom, so when I'm routing edges that need to have a precise depth to them, I can move this thing in and out and come up with the depth that I need. And again, all homemade stuff. I've got all kinds of steel and brass bits around the shop. Another site that I use when I need metal that I can't find locally is Online Metals, it's called. And they cater to the hobbyist. They'll sell you a 1 foot length of all kinds of stuff. Steel, aluminum, brass, all various kinds of alloys. Start this one that way. Now, the decorative screw on that thing, I've got another one. This is my depth gauge that I use, like for cutting dovetails. And I didn't like the commercial versions of this. One, because they cost about 30 bucks. And two, I couldn't find one this small. I like one that's going to really fit my hand, give me some control. I always keep chunks of cocoa bolo and rosewood around because I use a lot of it. I usually just buy one of these big turning blocks for bowls, and I just cut that up as I need it. So this is just made of cocoa bolo. The cutter in here, you know those box knives where you just keep snipping the piece of the blade off? Okay, that's just one of those segments in there. And then I shape that into the knife. But I wanted to mention this decorative screw. I'm going to start these the other way for a change, maybe.
Jim? Yes, I think he wants to take a picture of it first.
Picture of the thing? Okay. All right, those decorative brass screws for making this kind of stuff, you can order those online. I can't find them locally, and they're ungodly expensive. So if you go to your home center again and go to the electrical department where they sell lamps, there's a display of little bits and pieces for lamps. And this is just a piece of threaded brass that's used to cap off one of the threaded rods that you use for lamps. This is just a brass flathead screw that I've ground just a little bit of the head off so I can fit it in there. And you can super glue them or you can solder them. And the one that's on the piece that's going around for the router is soldered because there's another ring that has to be captured. But anyway, just take one of these things and stick it onto a flathead screw and you get a nice little decorative brass adjustment ring. All right, so this thing here was not that difficult to make. I had to solve a few problems and figure out how to particularly get that ring, that threaded ring in there, but again, no big deal. It cost me nothing because, like I said, I had all this stuff. If you look at that aluminum base, you'll see it's a 1/4 inch thick, but it's actually 1/8 inch aluminum. I keep little pieces of 1/8 inch aluminum sheet around. And you can just scuff sand, make sure you clean it with acetone, each one of those, and then you can epoxy those together, clamp them together, and that's not going anywhere. All right, let's take a look at my shop here real quick. My whole shop is one great big shop solution. I'm working in 300 square feet, 12 by 25. So looking at it from one end, you can see I've got things on the perimeter. And I always keep about 100 square feet open, floor space in the middle. And everything you've seen that I've shown you, even the dining room set, table, 6 chairs, and a hutch, was made in this space. Looking at it from the other end, you can see my lathe on the right. I got an 8 by 75 inch joiner back there behind the table saw. The table saw and the joiner are on mobile bases. So if I have to like joint something that's longer than I can fit through this way, I can roll the table saw out of the way and bring the joiner out. Table saw is an older Craftsman model when they used to be made by Emerson right here in the USA. Homemade side feed and out feed tables. And the way I supported those tables, I just used 3/4 inch electrical conduit, hammered the ends flat and bent them over, and you can see where they're screwed to the holes that are already on the table legs. That way the whole thing is on the mobile base and I don't have to worry about legs if I need to move that thing quickly. I've got my miter sled, and on the other side a crosscut sled that I just keep mounted on the base. Crosscut sled is pretty common. I didn't want to bring it because it's big and everybody knows what that is, but it's a must-have on a table saw. It makes cross-cutting safer and more accurate. When I bought that saw, I immediately upgraded the fence. I bought a bigger, beefier fence, and it's hard to see in that picture too, darn it. But that left me with the old fence. I still have the rails. I don't know what I'm going to do with those, but I'll figure out something someday. But because I have my router table built into the table saw, like I'm sure many of us do, I took that old fence and then I had to make an adapter to go to the bigger rail. So here again, exploiting materials. This is just made of stacked up plywood, and each piece of plywood I cut a 2.5 inch hole in it. So when I put them all together, I've got this like a half round 2.5 inch slot in there, and then took plumbing pipe. Now, plumbing materials are sized by the inner diameter. So if you buy 2 inch plumbing pipe, Schedule 40 plumbing pipe, and that's what I use for those clock weights, by the way, it's 2 inches ID. It's 2.5 inches OD, 1/4 inch walls. So this just happens to be a 2 inch diameter extruded rail, so that mates very nicely. And it's the kind of fence that when you push the lever down, it captures on the back. Kind of pinches the fence. That's a typical Sears configuration. So having that piece of PVC on there just made that a perfect mate for that. Look puzzled. You with me? Everybody good? My workbench weighs about as much as a small car. I made this thing in 1977, and then I've been tweaking it ever since. I keep replacing the tops. That's my 4th top on it because I'm not a real believer in fancy benches where I'm afraid to hurt the bench, use my benches. I don't have room for like a cabinet maker's bench in the middle of the floor, so I always work off the perimeter. Now, this thing, it's 4x4 legs that have been dadoed to accept 2x4 stretchers, so they're inset in the legs and bolted in, and it's a real solid way to make a table. But if you look at the top of the cabinets, and then where the top stretcher starts, on the top of the cabinets, I just laid a piece of hardboard, masonite, 1/4 inch, just sitting on there. And then between that and the bottom of the inside of the top of the table, I've got 3.5 inches of wasted space now because of that stretcher. Everybody visualizing that? All right, that table, if you look right below the blue vise, you can see a little black knob. There's one on each end. That locks the tabletop down. That vise can be easily removed, by the way. It's just bolted into threaded inserts, so I can take that off if I need that part of the table. So anyway, if I just take everything off the tabletop, turn those little knobs, I've got the top on hinges. I can open up the whole top, and that 3.5 inches of wasted space is now where I store my veneers. So in a 300 square foot shop, you start getting creative as to where to put things. The walls are all pegboard, and I don't think I could fit another screwdriver on them. And looking at it from the other way, I've got a radial arm saw on the end, and all that comes in handy for extra counter space. My drill press, I use the heck out of it, and I really like this thing. It's a Grizzly radial arm drill press. I bought the benchtop model. It's on an old table saw base. I built a nice big sturdy box to raise it up to working height. The box has got a drawer in it where I keep all kinds of things. A homemade work table, you can see. The beauty of the radial arm press is if I've got something that I need to drill and I don't have enough room between the quill and the post, I can just crank that table or crank that press out. It tilts, it turns, it extends. If I have something that's too tall that won't fit, I can clamp it to the 90-degree edge of that table and swing the drill press around, and then I can drill from that way. So very versatile. And just some of the stuff that's in that drawer. I keep a machinist vise on a piece of wood with knobs on it that I can put in the slots on the tabletop for when I'm doing metal work. And when you buy a commercially available version of these tops for drill presses, the work surfaces for drill presses, you know, they're made to sit on the readily available or the stock work table, right? But they always put a great big riser in there to give you room for the crank, the little short crank that's on your post. So I didn't want to waste that much space. I wanted to lower this thing all the way down. So I just took a piece of 1/2 inch plumbing pipe. This is just galvanized iron pipe. 1/2 inch, again, it's plumbing pipe, so you know the inside diameter is 1/2 inch. I just use that as an extender to get my crank out, so I didn't have to have that riser. And you drill and tap this stuff so you can put little set screws in there to hold it all together. Oh, and on that thing, that blue thing is a little 2-bowl doggy dish. That's mounted with a screw and a nylon washer, so I can spin it, but the screw's not going to come out. And all the stuff I use over and over and over again, little bits and countersinks and stuff I just keep in there. All right, my bandsaw is an old Jet. Remember when Jet was blue? So that was quite some time ago. But this is a really nice saw. It's really been good for me. I upgraded it with the Carter bearings. And I made my own fence for this years ago. And here again, exploiting materials. The rails are made of structural tube, and you can buy this if you go to the hardware aisle at the home center. You always see this big area where they got all kinds of steel and aluminum angles and bars and what have you, right? This is 1-inch steel, so because it's structural, in this case, the 1 inch is the outside diameter. And the reason I didn't use solid for this is because it's heavy, and it's harder to work with. So I bought the hollow, and then I took a piece of 7/8 dowel, because this is structural steel with a 16-inch wall. The inside is 7/8, and just inserted that 7/8 dowel in there. It took a little persuading, and then that gave me a little bit of more rigidity, and it allowed me to drill an counterbore. The wood gave me something to counterbore too for the mounting screws that mount this to the table. Now the fence is really accurate, but if you look at how that mates to the rails, I just made it's stacked plywood. I made a wooden base. Did it the same way I did that thing I showed you for the table saw. I used 1-inch plumbing pipe. Plumbing is 1 inch on the ID, right? So just a really nice precision slide fit over that 1-inch structural steel. You got that in there, and then sawed out a slot on the inside so it will be able to pass the mounting screws. That is, you can see there's 2 knobs on each side. The biggest one inboard just locks the fence to the rail. The other ones allow the fence to pivot on its mounts, so I could compensate for blade drift when I was resawing. But what I found over the years, when I started experimenting with resawing, I tried all kinds of blades. You know, I looked at commercial resaws. They got big wide blades on them. So I reasoned, well, I need the widest blade possible. This kind of saw, 14-inch saw, will take a 3/4 inch blade. Didn't work real well. I tried the wood slicer. Everybody's familiar with that. I didn't care for that. And then somebody told me about using 1/4 inch blades for resawing. And I've used them ever since. And I don't compensate for drift. I always set my fence perfectly square. And even for like this guitar side that's going around, I resaw that to a little over 1/8 of an inch before I thickness it. And I just set my table square and get a perfect cut every time. The bearing guides help. The key is the saw blade. It's actually the blade that causes drift in a bandsaw. It's not the saw itself. And you want to buy a good quality blade. You don't want to buy a blade where the teeth have been stamped. You want to buy one where the teeth have been milled. And experiment with your tensioning. I tension this pretty tight, more for what you might have for a 3/8 blade. And it works. And I don't even put other size blades on there. I use a 1/4 inch, 4 teeth per inch blade for everything I do. You can cut aluminum, you can cut brass with these blades. If I'm going to cut metal, I've got another blade I'm going to swap out. So when I'm resawing, I want my blade good and sharp. So that little feature for adjusting the table for drift doesn't even get used anymore.
What preference, manufacturer's preference, do you have on blades?
I'm buying, and I haven't bought any in a while, but Carter blades. Carter came out with their own line of blades. And my brother-in-law works for Carter, so he used to send me stuff when they were prototyping these blades. He sent me like a box of them.
Would that be free stuff?
for me, but it's a family connection. But anyway, I've been using those ever since. So, and I'm on my last one, so I'll have to buy some more of those, or talk to my brother-in-law.
Part with money then.
All right, this thing started out as a cheap, slow-speed whetstone grinder. You've probably seen these before. It's got a big water pan underneath, and it comes with a 10-inch stone. It's like a poor man's version of the Tormac. So I bought one of these many years ago, and it was worthless. The stone was worthless. Just wasn't a good machine. So I threw the stone away, threw the water pan away, and salvaged the motor and the gear mechanism for the slow speed. On the right-hand side, it actually came with a high-speed 5-inch grinder on it, which again, didn't need that. So that went away. So I did, using some bearings and some materials I'll show you in a minute, adapted the shaft so it could go all the way through, so I could have 2 slow-speed wheels on it. And then just turn these out of MDF, put some leather around them, and I use those for stropping. And I'm a believer in stropping. I strop my chisels, I strop my plane irons. So I can use 2 different grits of compound. I stacked up a bunch of pieces of leather and then went to the lathe with it and turned my end so I can strop my gouges.
What compounds do you use?
I'm using the yellow, I think it's chromium dioxide, but I'm not sure, but the yellow stick that I can buy at, probably buy it right here. And then I actually buy the Tormac brand of stuff that's in like a toothpaste tube. You know what I'm talking about? So I got the yellow stuff on the right side, and I use the white stuff on the left side.
You ever use semichrome?
I haven't.
Y'all try it sometime.
I probably will. Probably will. So for a lot of things that I do, in this case here, I use bearings, and my clocks each have one of this size bearings in them. This is 7/8 outside diameter. The hole is 5/16. This is just a 5/16 machine bolt. That the shoulder part of it is a perfect 5/16, and that works really well on a bearing like this. I buy these. I bought a whole bunch of them when I was making clocks, so I still got all kinds of them. Two sizes I use. This is a smaller. This is a 3/16 hole. But anyway, you can buy these at Lines. Just type in, I can't even remember the site, but type in hobby bearings as a search term, and you'll get several sites that sell bearings. But this particular size, 7/8 with a 5/16 hole, is a skateboard or rollerblade bearing. And people that rollerblade or skateboard have to replace their bearings every now and then. So you can buy these at sports supplies. You can probably buy them at like Dick's Sporting Goods or something like that. All right, for sharpening, gotta have a slow speed grinder. This is a very inexpensive Taiwanese-made grinder. I think I see one right up here. 1725 RPM grinder.
That's the woodcraft special.
Yeah, exactly. So when I was getting into turning, I was looking at all the Wolverine stuff, and again, really nice stuff. I can make that. So borrowed a wire feed MIG welder from a friend of mine, just a little portable MIG welder, and these things are incredibly easy to use. And just acquired some steel. The square tubes that you see mounted on the table. By the way, this table is a turntable. I've got my sanding station. I got a 10-inch 6x48-inch belt sander, 10-inch circle bander combination. Got my grinder, got that sharpener I was just showing you, and whatever one I'm using, I just spin the table and I bring that one out front. So trying to make the most out of an available footprint. But these square tubes are set on a diamond configuration, and they're mounted to the table, and then I can put these attachments in. I thought I brought that long one with me, but it's not here. But if you look at the Wolverine stuff, this is just copies of that. This is the one that's on the other side. This little platform in here, by the way, came with that cheap stone grinder I just showed you. So that was worth salvaging. Couldn't find this size tubing that I needed locally, so I went to Online Metals, bought a little bit of that, and just started welding things up. Now, the coolest thing I liked about the Wolverine system was this. So when you're turning a bowl or sharpening a bowl gouge, you want that nice, long, sweeping fingernail grind. Sometimes it's called an advanced grind. And this is how you do that. So that was a $75 attachment at the time. Again, I've got all kinds of steel around the house. I had the welder, so I just made this one. And very intuitive. You can see how this is made. This piece here, when you put your gouge through here and you tighten it down, that's just a little surface to secure the gouge. What I made that out of is just a piece of, I think that's 5/8 inch wide strapping material that you see pallets strapped with. So I didn't have to go out and buy a whole big roll of Signode stuff. I went to the Home Depot where they load stuff for people in the front, looked in a waste can. And there's all kinds of lengths of scrap in there, so I just like liberated one of them.
On that turntable there, is that a Lazy Susan?
In effect, it is. There's no bearings, or I didn't buy a Lazy Susan. It's just wood on wood. And because of all the weight that's on the table, and because of the way I made that wood, it's captured from the bottom. It turns
It
just fine.
spins on a bolt or something?
Yeah, it spins on a bolt. There's a center bolt there. It's actually a little steel post that it turns on.
Okay.
How do you lock it?
I don't. Again, there's enough weight on it. When I turn it, it's not a one finger thing. I gotta grab the ends of the table and turn it. So it's stationary enough as it is. And because,
Is the base heavy enough to keep
I'm
that
sorry?
from turning? Is the base heavy enough to keep it from turning?
yeah, you can see, let's go back a little bit here. You can see it in the background there. You know, the base is 8 by 8s in a cross, and then supported with gussets on the bottom, and then on a great big, it's like a 18-inch by 18-inch wide wooden base. It's sturdy, and I can turn it so the base isn't going to turn. It just came out that way. Got lucky with that one. All right. This is my lathe. I've got an older model Nova lathe that I really like. And again, when I was turning and started getting into some hollow forms, I was looking at all the various things on the market to do that with. And this is one of my hollow forms, and there's something else unusual about this I'll tell you in a moment. And online I came across this Jameson tool. Now there's several versions of this on the market today. It's basically a captured rear rest. And I didn't bring the rest with me, the rear rest, but all that is 1/2-inch diameter steel rods. There's 4 of them with a little piece of steel mounted on each end to hold them together. And that sits on a post on this thing, and you got to make this to match your lathe bed, so it'll sit in there tightly. And that's got a pivot when you're turning. So that's that part. But the guts of this thing is the frame. This is solid steel, not tube. When I had the welder, I made this. The miters, I just put in a vise and cut with a hacksaw, and then go to my sander and sand them smooth. And these are the tools that you see that go into the thing. This is just using some aluminum tube that I had. This is the laser guide, which really comes in handy. You can see it put together there. This is from Office Depot. It was a $4 laser pointer that works really nice. And these tools, again, the same steel that I used for that, 3/4 inch diameter, cold rolled steel. Drilled a hole in the end of it so I can get my attachments in there. This retainer ring for the cutting tool is just a piece of this cut off with a slot filed in it, did some drilling and tapping. And then made several different attachments for it. This one would be for particularly severe cutting on a bigger bowl. I made a gouge attachment. I haven't seen one of these available commercially, but I can get really aggressive with that thing. And this is literally, if you've ever done hollow turning, done hollow forms conventionally, the tools have handles that are that long on them. You got to have that kind of leverage just to control the tool. There's a system where you have this thing that actually wraps around your arm, because you got to hold that tool steady. And if you get a catch, you could break your arm literally. You could have that tool fly up and hit you in the face. This is literally one fingertip turning. I mean, it's a remarkable way to turn. Very safe, and if you get a catch, one of 3 things is going to happen. You're going to stall the lathe, you're going to break your tool, your cutter, or you're going to break the bowl. But you're not going to hurt yourself. So if I have a choice, break the bowl or hurt myself. Let's see. All right, so this is just, I think that's 3/16 diameter tool steel. I haven't seen these around lately. I used to buy these at Highland. And they come in like a 2-inch length. I've still got plenty of it. And I just make my cutting tools out of that. And you can see how kind of straightforward that is to pass that around. So that was a little bigger hollow form that's on the lathe. This is kind of a smaller one, but it's a true hollow form. This is from a sweet gum tree that we took out of our backyard. You can see it's a crotch. So I just cut that crotch out and made this bowl. But what I really wanted to show you on this, that big bowl that I showed you is finished this way as well. Is I was trying to come up with a good finish with this. And I really don't like the idea of spraying 40 or 50 coats of lacquer in a bowl like this and sanding and doing that. I wanted to come up with something a little one step. So what this stuff is, let's pass this around when I'm talking about it, is that two-part epoxy that you use for those real thick tabletops. I use the Pour-On brand. I haven't tried System 3, but I'm sure it works just as well. And that stuff cures really slowly. If you're making a tabletop, it's going to take 24 hours for it to even harden up. And it does that so it allows the bubbles to come out. So you get that nice smooth finish. So I mixed some of that stuff up, and I had to experiment with this a little bit. And I rig my bowls up, I mount them in the lathe, so I've got them captured internally. So I've got access to the whole surface. I've got a DC motor on the lathe, so I can get that bowl turning like this slow. And I'll just take a foam brush and coat this whole thing with that epoxy. And it looks like crap when I do that. Then I turn the lathe on and get it turning slow, and I'm going to tweak it a little bit, spread it around the best I can until I'm satisfied. And if you don't keep the lathe turning, it's all going to slide off, right? And I got to keep that lathe turning for about 8 hours. But I can get it to the point where it looks okay and I can just walk away from it. And in about 8 hours, it's set up enough so it's going to stay there. And just turn the lathe off and leave it sit there for a couple days. And it comes out so glossy, I mean, it almost looks like plastic. It's too glossy, that kind of fakey look. So I hit it with a piece of Scotch-Brite, start spinning the lathe, and just knock some of that gloss off it, and come up with that kind of a look. And it seems to work pretty nice.
How slow do you able to get your lathe down to do that?
I haven't measured it. You know, it's on a potentiometer that doesn't tell me how fast it's turning, but it's going about like this.
Hard to get most lathes going that.
Yeah, you got to have a DC motor with a variable drive on it. You're not going to do that with just belts.
But even Powermatic, the new Powermatic's don't go slower than 50.
Really?
The older ones, you bring it down to 0, but all the B models, 50s is slow.
Yeah, this one I can bring down to 0.
The Jet 1642 probably the same.
Yes, sir.
A rotisserie motor, if you could hook
Yeah,
up that might.
Yep, that would be a good idea. Yeah, anything that you can, you don't have to have a lathe to do that. You have to have a lathe to turn the bowl, obviously. But I was making some putters, golf putters for a while out of wood and brass, and I was using the same finish on them because it's a good tough finish that's going to hold up. And I chucked those up in the lathe to turn them like that. But a rotisserie motor or something like that that turns real slow would work just fine for me. Yes, Vanessa?
I've seen that you brought it Epoxy and Hobby Lobby. Where do you buy yours from? Because I know you get that.
Well, epoxy for structural use, I buy Hobby Lobby is one place. Two-part, I use the 5-minute, I use 30-minute, I use 12-hour. Like that veneer that's around the tubes for my clock weights, I want that to take a while to cure, so I use a 12-hour. But this is something different. This isn't structural epoxy. This is made for tabletops. You've been in places where they've got a wooden tabletop and the finish looks that thick.
Yeah, they sell some of that in Hobby Lobby, but it's...
Do they? Okay. Yeah, they sell it here. They sell it at just about any wood type store. Various brands. Some of them, the Part A and the Part B, are different size bottles, so you got to be a little more precise. One of the things I like about Pour-On is they're equal amounts, and I've got a little postal scale, so I actually weigh the amounts when I put in this stuff together. But you can estimate, if I'm using a small amount, like for a putter, I'll just pour out a capful of each one of them. I keep a supply of little plastic bathroom cups in my shop for mixing this kind of stuff up with. Yes, sir?
When you're doing something like tapping and these boring bars, do you have access to a metal shop, or how are you doing that work?
Remember the blue vise that was on my workbench? I've got a limited number of taps, just the size I use.
Not like drilling into the end of the bar.
Oh, okay, I'm sorry. I chucked that up in the lathe.
Just a wood lathe?
Yeah, it's a wood lathe. Now, I've got a number of these Nova chucks. This is the old model. But the one that I have that's got small jaws on it, they'll close up to 3/8 of an inch. So for that 3/4, and of course, then that goes all the way through and comes out the back of the lathe.
Okay.
So that motor you see isn't on the back of the lathe, it's offset. So I'll just chuck it up in that, and then in the tailstock, I just put a Morse taper drill chuck in there with whatever size drill I want to use, and then put the lathe at an appropriate speed. Use a little 3-in-1 oil while I'm drilling steel, and just drill the hole that way. Feed the drill into the spinning lathe. Yeah, good question. I should have covered that. When I was showing you that 3/8 threaded rod on that little router base going around, I put that in that same chuck and just put a drill bit in the tailstock chuck and drill it that way. All right, a couple unique things here, but this will have application for you. This is a piece of Honduran mahogany 4x4 that I can cut guitar necks out of. So these are, I can get 2 necks and the wood to make the tail and the head blocks for the guitars. Now the necks are dovetailed onto the body of the guitar. So on the end of that piece, there's a dovetail cut like this. And then the block inside the guitar that cuts through the front is cut like this. And you need templates, and I've got a fixture that I attach these templates to that I can hold that neck and the body block in place. And I just make my router templates for all kinds of different things out of 1/4" MDF. And when I make these, I take a thin CA glue and just start pouring it on the edges of this. It gives them a nice hard surface and it'll make them last longer. But you got to make these things precise. So I'll make one first, make sure I get what I want, and then make the other, and then just start tweaking them. When I'm working these sides, I just take a couple of steel bars that I keep, like 1/2" by 1/4" steel bars, put them in my vise, and clamp those up to the edge that I want to work, and then file it. Use those steel bars as a guide for the file so I can get a nice straight edge. But what I ended up with, these are my prototypes. I took a few pieces of basswood, and you can see I stacked them up and just made a long piece of basswood and started cutting pieces off to experiment with, and probably had to do this 6 times to get where I needed to get. But when this goes together, I'll pass this around in a minute. If I put just a little bit of pressure on this, it's actually hard to get apart. And it pulls that back end of the guitar neck right up to the body, and it's in there solid. And when I glue it and clamp it, this will actually go flush. So you just had to play around with it to get it as precise as I wanted it. But when you're making templates for anything that you're doing with a router, this is a good way to go. MDF is really easy to work with and cut what you need. But make sure you're coating the work surfaces with some super glue, because you know how MDF tends to separate sometimes? That'll keep that from happening. That's a picture of the end of the neck with the dovetail cut on it and the front block of the guitar. All right, putting the guitar together, you need cam clamps. Now these things have just the right amount of pressure, and they sell them just about any woodworking store, and they run between $15 and $20 a piece. As you can see, I needed a whole bunch of them. So I made what I needed out of scrap wood I had around the shop. Oak, and I think this is a piece of Hatoba. And this is really easy to make. And the way I go about making things like this is I go to the store and I look at the thing, look at the one that's available. How does this work? How is this made? And then go home and make a prototype and then work from there. The hole is cut with a hollow chisel mortiser. One size I made, so I actually make this second, make the hole first, so it precisely fits. The other side, I just took a sanding stick and made it a little bigger so it would sand, or so it would slide. Made some long ones, some deep throat ones, made some shallow throat ones. And the make-buy decision was easy on this one. I made 22 of these, only because that's all of this that I had. So let's say low end 15 bucks. What's 22 times 15? Do the math, it's like 320 bucks. That one is a real no-brainer. All right, that router base that I was passing around, by the way, make sure all this stuff makes its way back up.
You know how to make another one.
The binding that goes around the perimeter of the guitar, that's that white stuff you see on guitars, and the purfling. We'll go back to one of those. All right, you can see the white plastic binding. You buy that in lengths. This has a herringbone pattern purfling around the top. You got to route channels to accept that stuff. And that's what this was intended for, is to put on my little router and route those channels. And when I'm doing the top of the guitar, that's flat. That's easy enough. But the back of the guitar is radiused in both directions. And if you hold that router base flat, then the router bit's going to be like that. And just getting that precise is really hard to do. So another way to do that is with this simple little thing here. That just clamps to my router table. I use a 1/4-inch spiral upcut bit. Which, by the way, when you go to that StuMax site, this is the only place I've seen these. You can buy 1/8-inch shank spiral solid carbide straight cutting bits, down to 1/32 of an inch diameter. And they're used for guitar use, but they're great for inlay use or anything else you need a little bit for. But by raising a 1/4-inch bit up through here and having just a real small table to rest the guitar on, all I got to do is make sure the guitar side stays parallel to this guide. And I can adjust for the depth of cut this way, raise or lower the blade for the other dimension. And you can't see it in this picture, but that top, it's the bottom that's actually facing the top right now, has a step cut in it. So if that's the big surface and that's the side of the guitar, I want to make a cut, and I'm going to exaggerate this. That's like that. So that plastic binding fits in here, and then the purfling fits in there. And this does this thing amazingly precisely. And it's just a very simple thing to make. A couple threaded inserts and some thumb screws for the adjustment. And I'm sure it's got a bunch of uses besides this. The fret wire, that's the, you know what frets are on a guitar, has to be radiused. The fingerboard is actually radiused, and in this case it's a 16-inch radius. And you can't pound straight wire in there, because it'll always want to pop out, so you have to radius it. And you can buy these radiusers for an ungodly amount of money. Because I keep this size bearing, this roller blade bearing around, I just stacked 2 of them with a little washer in between it to get that groove and the tang of the fret wire rise in the groove, and then adjust these bottom 2, and you crank the wire through and it puts a radius on it. And I thought about making a fancy handle for this thing, but all I need to do is put a 1/2-inch wrench on here when I'm using it and turn the wire through. You want to see this thing? Okay. So, and then I've got this old, like Harbor Freight version of the Black & Decker Workmate that I've had for I don't know how long. On the left is just plywood at 90 degrees with some gussets. There's one on each end. I used furniture upholstery foam on the inside of it. And that way I can set the whole guitar body in there while I'm scraping. Which, by the way, what I'm using for a scraper there, who uses scrapers? This is just a razor blade from a box knife. If you put that in your vise and present your burnisher to it, you can bring a nice little edge up on it. Now I'll go to my sander and take the sharp ends off just so I don't hurt myself when I'm using it. And it's a great little scraper. And you can't get the edge, the hook, that's what I'm thinking of. You can't get that going both ways on a razor blade, just one direction. But just a real handy little scraper that I scrape that plastic smooth with this thing. And this is called a go bar deck. Anybody ever seen one of these before? For any kind of clamping that you want to do that you usually weight things for or clamp onto a table, this is a great thing to have. If you've got a workbench with cabinets overhead, you've already got your deck. The bars are made of 1/4-inch dowel with little rubber tips on the end of them. These things are sold, they're made of fiberglass with little rubber tips on the end, and they cost $4 a piece. So 1/4-inch dowel. Go to your home center where they sell the wire shelving that you use in closets, and you can buy a bag of 100 of those little rubber tips for like $5. And then you just wedge, in this case I'm gluing the braces to the inside of the guitar, and you just make the MDF 4 holes cut in this, and in this case 5/8 rod bolted together. You can raise and lower that depending on how long you've got your pieces of wood cut. But you can see those 1/4-inch pieces of wood are bent, so you just wedge them in there. And you hold your, whatever you're gluing down that way. And that's just a top and a bottom all braced up and ready to go. Alright, so that's the end of the slides. And we're getting close on time. See what else I have to show you. A couple other little miscellaneous things here real quick. For turning, you need something that you can put in a drill and sand with, right? Bowl spinning, tool spinning, you get a nice smooth sand, and you can buy all these commercially available things. And when I first started turning and was looking at these, the price that really got me is the refills for them. So I actually went to a toy store and bought a whole bag. I could only get a bag of rubber balls, sponge balls, and then cut them in half. Oops! See how strong they are? Just turned a little ball, epoxied that piece of rubber in there, glued on a piece, in this case leather, so I could use PSA sandpaper. This one, I put a piece of double stick Velcro on it, so I could use, cut up some pieces of Velcro type material I have. And then I've made several of these, so I've always got various grits handy. They work very nicely, and they cost almost nothing, close to nothing. And another version of that is just using a cheap one of these, like the Harbor Freight version. Taking a piece of foam, this actually came out of a crate that some electronics came in. And you can actually present this to your belt sander. You got to really keep control of it because it'll grab it and shoot it across the room. And you can shape this, but I shaped just a little bit of a dome on it. Used some double stick Velcro. This is just a piece of Scotch-Brite. And some of this stuff you make up right on the spur of the moment. So when I was working on my first guitar finish, using Scotch-Brite as one of the steps in working the lacquer, in order to get right into that place where the side is bent, I needed something like that. So I just came up with that. And again, cheap, easy, quick, works great. If you're drilling into a bowl for depth, I use a Forstner bit for that. This is a piece of 3/8 steel rod you can buy anywhere. a 3/8 coupling nut is called, which again, 3/8 rod just happens to slip right in there. And drill and tap for some set screws, and I can put a Forstner bit in there, and I've got a good extension for the lathe. And then finally, this monstrosity here, some of you have seen before. This was my real crazy, what are you doing type project. But going back to that dining room set that I showed you, when I made that thing, the 6 chairs consisted of a total of 108 mortise and tenon joints. And some of them were angle joints. And the mortising I did on a hollow chisel mortiser, and I would probably do that again. I think that's the way to cut mortises. The tenons I cut on a table saw, and you all know how to do that. You set a stop in the blade to cut the shoulders. Let's just take a look at one here. All right, this is an angled tenon. I'll talk about that in a minute. But you cut your shoulders, you turn it, you cut the shoulders. If you want these shoulders to be a different height, you got to tweak the blade. Then you turn it around. Every cut you make, you got to reposition the wood. It's slow, reasonably accurate. I use a tenon and jig to do that cut the cheeks off. Angle tenons, you got to angle the blade. And table saws only tilt one way, right? I got a left tilter. Angle the blade, and then come back this way and try to get all that in the same plane. And then go back to 90 on the blade and then turn your miter gauge to do that. And I thought, God, there's got to be a better way to do this. So after I did all that, I started looking for what's available, and there's all kinds of things available to make mortises and tenons. And I ran across this thing called a shop fox. I think it comes out of Australia. And I liked what I saw, except for the $800. And certain things about what I was seeing, I thought, yeah, I don't like that feature, etc. So I decided to try to make something. This is my 3rd incarnation. I made one, worked okay, needed work, made a second one. I was getting there. This is my 3rd one, and it works pretty nice, and it still needs some adjustment, or still needs some tweaking, but it works. I use an older model DeWalt router for this. Now, this whole thing here has got drawings to make each one of these parts. It's full of photographs and text to explain how I made it and how it's used. And I gave Rob a CD, not a DVD, just an old CD that's got all this information on it. So if you guys are interested in it, make copies of it at will and have at it. All readily available materials, with maybe one exception. There's 2 bearings in the ends of this. This is what runs the table. There's just a 5/8 diameter threaded rod through there. And what really surprised me about doing this is there is no backlash. And you stop and it stops, and there is 0 backlash there. But when I made this back in '04, these bearings were available in one of the drawers at Lowe's. And it's actually a replacement bearing for some kind of a pump that just happens to work with 5/8 rod. If they don't have those there, go online and you can buy bearings just about anywhere. But let me show you some of the capabilities of this thing. Besides angled tenons, you can see the beauty of this thing is, before I pass this around, is you put the piece in here, and then the router is going to move back and forth, up and down with its own plunge, and then on this plane with this, the piece stays put. So in this case, I'm using a 3/8 straight cut, upcut bit, spiral bit. Everything is right in the same plane. It just does a near perfect job. Playing around with it, I was just doing some of this kind of stuff just to see what the capabilities were. And another really obvious thing to make for this thing is box joints. Just use a 1/4" straight bit in this one, and again, this manual is going to show you how to lay all that stuff out. That's assembled and not assembled. Came up with a way to make through dovetails with this thing. These are really nice precision tight dovetails. If you're going to make dovetails with a router, by the way, no matter what system you use, you're always going to end up with router geometry. You can't get a bit that's going to go smaller than the shaft of the router. If you're going to cut dovetails by hand, if I'm going to do something like this, I'm going to cut that by hand. But when I'm using the router on something like casework, I figured out how to do it on this machine. So I made some boxes that way. Yes, sir.
How big a piece can you cut on
On this particular version, I can go up to 13 inches wide. But you can make this as long as you want it. All discussed in the manual. And then, that little table I showed you that had the oak finish on it, I used pin and crescent joints on that table. And there's somewhere in the world, there is a router jig available to make pin and crescent joints. This is an old world joint, basically that came out of the Grand Rapids furniture movement before commercially available dovetail materials came out. They were making joints like this, and I always liked that joint. It's very pretty. And I figured out a way to do it on this machine. Now, the only difference between this and the real thing is on the real thing, that pin is actually integral. It's all cut out of that piece. So in my case, I just make two pieces like this and glue them up and then go back and drill these holes and then cut with a little dowel cutter, cut the pins to put in here. But when I was really kind of getting creative with this machine, I figured out a way to do that with it. So all that various stuff you can do on this thing. So that's one of these really crazy, far-fetched, out-of-the-box, homemade things that I just got in the mood one day and decided to give that a shot. Okay. Any questions?
Yeah, you got your, for holding the bowls and stuff, so once you turn them around over in the corner over there?
Oh, you know, I didn't even cover that, did I? Now, these are called coal jaws. You can buy these, of course. Because I keep this 1/4 inch, actually 1/8 inch aluminum around, and I epoxied it together to make 1/8 inch and just drilled and tapped. This stuff here is just a big sheet of plastic. It's not the ultra high molecular density stuff. Some kind of a structural plastic I got at a place I used to work. It's like 1 inch thick, and I got a nice big sheet of it. But I cut things like this out of it. So I've got several different types of these attachments that go on here. This is just an old style Nova chuck that I dedicated for this purpose here. So that's for turning bowls. You've all seen these things, right? And let's see, there's one more thing I didn't show you. I said the guitar fingerboard is at a 16-inch radius. So the first fingerboard I made, my first fingerboard I used, I bought one already radiused. And then I used a scrap piece of that as my reference for this. And cut this on a table saw. And raised the blade and cut the middle, tilted a little bit, and kind of got that roughed out. And then made a profile scraper and scraped it, and I took this piece of fingerboard and taped, or put a piece of double stick paper to it, sanded it. Then I just have to put double stick paper on this. Now I can radius my own fingerboards. That works pretty nice. All right, so just like I said, we're going to look at a whole lot of different things today, which I think we did, and I gave you a little bit of insight. Looking at available materials and figuring out how they're sized and dimensioned. You know, 3/8 bolt is always going to be 3/8. The outside diameter of the threads is going to be 3/8. Plumbing, structural, whatever you're going to buy, look at how this stuff is made and how can you use them together to do certain things that you want to make. Things that have to slide, things that have to turn. Where can I find metal? If I need brass, go to Online Metals. And you just kind of got to start getting into the feel for it. And I go to sewing stops or shops. Carl just told me about this place across the street. What was it called again?
Global freight.
Yeah, Global Freight. I've never been in there, never heard of it. But you can bet I will be. And where do you find stuff? Hardware stores, there's some really good old-time hardware stores. I use one because it's close to here actually. It's at the corner of Buford Highway and Button Gwinnett. It's called Howard Brothers. Yeah, but they got the most amazing array of screws and nuts and bolts, aisle after aisle after aisle.
There's another one in Duluth, of Buford Highway North.
Yeah, they got two of them. This thing here is a crank that I wind my clocks with. And inside here, I use a 5/16 bolt because it goes in that bearing. And file the end square. And to wind it, I used to use fireplace keys. Because, you know, you wind a clock with a key, right? That little thing, oh, that's not even on
That's
anymore.
not on the screen.
That's why you were flashing.
Give it a second.
Oh, okay. Right down there at the bottom on the left picture, little piece of square sticking out. It's a 5/16 bolt, you know, just the shoulder portion that I use for my raw material. File the end square to a 1/4 inch. And again, a fireplace key was nice, but it takes forever to wind. So I made a crank. If you go to any good hobby store, they've got a little metal center where they sell little pieces of brass. You can buy tubes that are like 3/32 outside diameter. This is just a piece of square brass that's not strong enough to do that with, so I just drilled out a piece of my 1/2 inch aluminum and epoxied it in there, and it made it look pretty. But what made me think of this is brass, in this case 832 acorn nuts. Where are you going to find those? Howard Brothers. You know, I haven't stumped them yet. But you just go in there and look around, even for stuff you're not looking for, because that's going to come in handy someday. Stuff you can't find at your big box stores. Find a good hardware store. There's still some of them left. So you just find all these places and sources so you know where to get materials, start thinking about how they all relate, and then decide, do I want to make something or buy something, and just go for it from there. So hopefully I gave you a little useful information today. I certainly enjoy this. It's like all of us woodworkers, we like to show off our work. That's always a great thing for me. So thank you again for having me. I appreciate it.